Hello everyone, and thanks for attending my presentation. Today I want to talk about an introduction to encrypted network traffic classification with application of machine learning. I am Navid Malek Qaini. I'm currently a graduate research assistant and computer science student at University of Waterloo. So the presentation begins with the one ordinary situation, and then we move on to the meaning of traffic classification, and furthermore I will introduce encryption and its challenges for traffic classification, and in addition we come up with leveraging machine learning for traffic classification, and after that I will introduce a general deep learning framework for traffic classification, and finally we go back to the one ordinary situation that I have introduced at the first of presentation. So consider this situation where you are downloading the data over the internet, and while you are downloading you receive a call on WhatsApp. So here most of your bandwidth is used by the downloading application. So you may incur some delays with the call, and with these delays more and more growing, you become frustrated and even you may not be able to continue your call. So one solution here for the ISP would be to give better service to call traffic. This includes to detect the call traffic within the other network traffics that coming from your end, and also prioritize the call traffic temporary over the others. So this will lead us to traffic classification. Traffic classification means characterizing and categorizing computer network traffic known as traffic classes. There are different types of classes. For example, as you see, this raw traffic we see on the internet can be categorized into classes such as different applications, for example, Netflix or Facebook or even Skype traffic. Also, we may class them for services, for example, whether they are downloading classes or voice over IP traffic. And then after we classify those traffics, we can treat them differently based on our need. For example, quality of service, better service for that traffic, or detecting malicious traffic for intrusion detection system. Encryption is now while around because of the privacy it gives to the users and also protects the data from the adversarial attacks. This is done via cryptographic algorithms. As you see, this plain text here is encrypted with cryptographic algorithm and a key that you and the other end you trust have, and that ciphertext is what the other people on the internet see, and only the other end you trust could decrypt the ciphertext into the plain text to see the information. So we as the interceptor or the ISP do not know what is this information exactly. This makes encrypted network traffic classification hard by simple methods or by hand and manually. So we will use more advanced technique. Moving on to machine learning. So we use machine learning for encrypted traffic classification, but the pure machine learning algorithms and classical machine learning algorithms were mostly involved on unencrypted traffic. For example, they use IP addresses and port numbers. These are not enough because they are not only prone to change, but also some other applications may disguise themselves as other applications. For example, another application which uses a different protocol than HTTP may use the 1080 port, which is associated usually with HTTP protocol for itself. And also the method of deep packet inspections which rely on patterns in the data are not usable here because the traffic is encrypted and the patterns are not the same every time. So we use statistical features such as mean, average, and variance of a flow. And also we may use time series features such as inter-arrival times. These features, these statistical features, are applicable both on unencrypted and encrypted data. But some protocols make this application harder, such as Tor, that uses some obfuscation in the patterns of data and the size of it. So it will give us some challenge, but not that much. But these methods are still handcrafted to some level, and also these classical machine learning methods have also their shortcomings too. So we will use more advanced ML methods such as deep learning. Moving on, I will introduce a general deep learning framework for traffic classification here. The first step is problem formulation. We decide that we want to implement which application, quality of service or resource planning, which kind of traffic we want to classify, websites traffic or applications, or more importantly, we want to have online classifier, which is to detect traffic on the go and very fast, or offline classification, which is analyzing the traffic we have stored and we want to analyze it after we have the traffic. After that, there is a data collection step, which is to decide we want to have real data, for example from an ISP, or we want to generate the data by tools or automatic libraries, and it will be named synthetic collection of data. We also decide where to collect the data, at the client side, server side, or at the core of the network. Okay, we decide this based on the feature set we want to use and also the representation of the data. The data should be diverse and abundant in all of the classes. So, when we want to use real data, we want to classify the applications. One application may not have that much users. This will make our model harder to understand and classify that application. And the next step would be pre-processing, which is extracting features from the data, like the statistical features that I have just mentioned, and also removing the information we don't want, known as data cleaning. After that, we extract all the different parts of the features we want, like headers, payload data, time series features, and also statistical features. And we later on implement our model. These are some known models in deep learning for traffic classification, each of which have their own benefits for different set of features. For example, if we want to use statistical features, then multi-layer perceptrons would be just enough. The next and the final step would be training and validation. In this step, we break the data into training, test, and validation segments, and also we define our strategy for training. And based on our results, we will tune the hyperparameters either manually or by some automation library like CrossTuner. There is also another step discussed, which is periodic evaluation and update. It is to generalize the model. It's still preliminary and an open problem, which is to adapt to make our model adaptive to newer classes and also new and unknown traffic applications. One solution here would be transfer learning. Back to the one ordinary situation. You are downloading a video, you receive a call on WhatsApp. This time, your ISP has encrypted network traffic classification. It knows which traffic involves your voice call and which traffic is the downloading of video. So it will prioritize this traffic temporarily and will give you a better service, and you're more satisfied now. Thank you for your attention, and you're welcome to ask any questions you have. You may contact me through email, LinkedIn, my blog, or even GitHub. Thank you.